Oh, I didn't see you there. Are you here to read this book with me? Oh. Are you here to learn about economics? Good news for you. I am a professor in economics. Just let me finish up my reading on economics. Alright, I'm going to start you off with the basics here. My name, Professor Siebert. I have a teaching assistant named Brett. And today, we're going to be teaching you two very important lessons in economics. One in macro, one in micro. The macro being real and nominal interest rates. The micro being oligopolies and game theory. In Econ 102. Interest rates. They're not always what they seem. Let's say a bank has an ad out for 5% return on your money in interest rates. Well, I hate to break it to you, but you're not always going to get that 5% back because the inflation rate comes into toll. Now, nominally, you will get 5% of your money back, but with real, the inflation is going to take back the purchasing power in your purchase. We're going to start off with some nice definitions. We got nominal interest rate. Interest rate that you earn or pay on a loan. Real interest rate. Nominal interest rate adjusted for inflation. This is the effective interest rate that you earn or pay, which is why it's called real. It's the actual purchasing power behind your investment. And then we go over to the Fisher effect. The idea that an increase in expected inflation drives up nominal interest rate, which leaves the expected real interest rate unchanged. Now what's the real world application for all that mumbo jumbo I was saying over there? Well really, it comes down to the banks and how the lenders make money and how the borrowers earn money. So it all starts off with this equation here. The nominal interest rate equals real interest rate plus expected inflation. This is the equations banks use to come up with the number that they're going to charge on a loan. So if the bank charges you a 5% loan and they expect there's 4% inflation, even though the nominal interest rate is at 5%, they will only be making a 1% gain on their money. But let's say the expected inflation was wrong. Then, if the inflation in our example goes up to 6%, the borrower is actually gaining 1% of purchasing power back because they don't have to pay as much on their loan through real interest rate. Nominally, of course, they're still going to have to pay that 5%, but the purchasing power behind the money that they have to pay is not as much as they borrowed it for. So this goes into the actual form of the equation. I equals R plus INF subscript E, where I equals nominal interest rate, R equals real interest rate, and INF subscript E equals expected inflation. So this is the real world application of it, and basically this is the actual application of it, where real interest rate equals nominal interest rate minus inflation. This is used for calculating real interest rate after. This is based off of projections, this is based off of fact.
Alright class, I'm teaching assistant Brett and we're ready to do some econ. Let's get to it. Alright class, now we're down to the point of oligopolies. It is a market structure in which a few firms dominate, and you can kind of relate this to a cell phone business like AT&T or Verizon. There's only really a few of them, and they all kind of what they do, it's like interdependent on each other. So if one company lowers prices, then the others are going to have to lower prices. So you often see in oligopolies, some companies may form a little truce with each other so that they don't have to compete as much or lower their prices. Now we'll be heading over to the graph here, and you'll see the marginal cost here. You got your price, quantity, all that good stuff. And you'll notice that this graph may seem a little different compared to others. It's got a little kinked curve right here, as they call it. And that's just a result of competitors decreasing their prices to match each other, but not raising them to achieve the same effect. And the steep curve is due to sticky prices, where oligopolists assume that other oligopolists in their market will not follow with price increases of their own. And you can kind of, as I said before, back to AT&T and Verizon, say one lowers their prices, then the other ones have to lower their prices, and overall they're just not making as much money. However, when companies do work together and they make sure not to lower their prices, and maybe even they all increase them at the same time, this is not legal and is what's known as a cartel. And that will head us over to the prisoner's dilemma. So as I was saying before, independence always going to play a big role in these oligopolies, because, especially in the prisoner's dilemma here, because what one person does will affect the other person's decision, and it'll affect what happens to them as well. So to explain the prisoner's dilemma, we'll start off talking about prisoner 1 and prisoner 2. If they both decide to talk, they'll both be sentenced to 8 years in prison. However, if prisoner 1 remains quiet, prisoner 2 talks, prisoner 1 gets 10 years in prison, and then prisoner 2 is lucky enough to get away with nothing. And this also works vice versa, where prisoner 1 talks, prisoner 2 stays quiet, and prisoner 1 is with 0 years, and then 10 years. And then the best scenario for both of them would be to stay quiet. If they both stay quiet, they both get nice 2 years. Now we're going to get into the dominant strategy for prisoner 2. Let's see if prisoner 1 decides to talk. Prisoner 2 is going to want to also talk, because 8 years better than 10 years. Prisoner 1 remains quiet. Prisoner 2 is still going to talk. 0 years better than 2 years. Now, when both prisoners choose their dominant strategies, this is what you want to call a Nash equilibrium. And you'll see right here, so we're going to have prisoner 1, he is going to be talking. And prisoner 2 is also going to be talking. And you see it's a little bit ironic, because although they both chose their dominant strategy, they're both still getting 8 years in prison, where however they both remain quiet, they each would have been taking 2. But it's not the way life goes sometimes.
All right, class. All of you still awake?
Yes, you.
Oh yeah, well all this is great and all, but like when are we gonna get some practice problems?
Right now.
Son, I got you. We're going to start off with a nice example problem for real and nominal interest rates. Tywin knows he has a debt to repay soon. The bank charges him an interest rate of 6%. If the expected rate of inflation is 5%, how much interest is he effectively paying? So when you look at this problem, the question that it's really asking is, what is the real interest rate that Tywin will be paying? So we're gonna walk over here to our nice equation. We got real interest rate equals nominal interest rate minus the expected inflation. We know from over here that the interest rate and or nominal interest rate is 6%. We know that the expected rate of inflation is 5%. Now after some complicated math, just let me grab my calculator. Alright, and we got 1%. This will be the real interest rate, or how much Tywin is effectively paying.
Alright, now we are going to be entering the FRQ for oligopolies. I'll start off by reading this long problem. Subbase and Just Subs are the only two sandwich shops serving a small town. Each shop can choose to set high or low prices. The payoff matrix below shows the daily profits for each combo of prices the two shops could choose. Considering both shops know the information shown in the matrix, answer the following. Let's head over to the actual question. Does each shop have a dominant strategy to set a high price, a dominant strategy to set a low price, or does it have no dominant strategy at all? Now we're going to head over to the matrix here to figure out the answer. Now, let's just check out, let's see if Just Subs has a dominant strategy. So, well, if Subbase goes high, then Just Subs is going to want to go high as well, because making $105 is better than making $40. Now, if Subbase goes low, Just Subs is going to want to go high, because making $120 is better than making $75. So, yes, Just Subs does have a dominant strategy of the high price. Now let's see if sub-base has the dominant strategy. Now if just subs goes high, then sub-base is going to want to be low because $180 is better than $110. If just subs goes low, then sub-base is going to want to go high price because 130 is better than 70. So in this scenario, sub-base does not have a dominant strategy, and their best decision here would just do the opposite decision of whatever just subs does. Now I'll be heading over to part B of this question. If the two shops do not cooperate on setting prices, what will be the profit for each shop? Alright, let's head back over to the answer matrix and we will find out. Now let's say they are not cooperating. You just look at the little matrix here, you see just subs, highest price, $180. They are going to want to go high price because no matter what, $180 is the most possible they can make in a daily profit. Sub-base, they're going to want to go low price because then they'll be making $120. If you look at the matrix, $120 is the most they will be making in daily profit. So that is the answer to B.
Did we all learn a lot today, class? I have good news for you. As someone that has taken the AP test many, many times, none of what we talked about today will be on there. So I will see you.
No, I'm gonna be late for my bio class. I gotta go. Thank you. See
Wait,
you.
did you say bio?
Yes.
All right, let me just put my economics away. Let me grab my bio book. Let's start.